my name is Bhushan Balu, working as an assistant professor AI and AS department, SNS College of Engineering. So today I'm here with a new topic in continuation with the previous topic, that is dealt with Unit-4. The first thing that we are going to see today is what is stochastic optimization generalization in neural networks. We saw what is optimization is, we saw what is non-convex optimization is, and based on the previous videos, today I'm here to discuss you about this topic. It is very easy and it is one of the simple topic which I am going to discuss today. What is this stochastic optimization? So this presentation, it actually explores stochastic optimization and how it works in the neural networks. We will cover there are certain different challenges and techniques for achieving the robust performance. What is robust? Robust is something which you have to be faster enough and you have to be quick enough. You have to access the process in an efficient way. This aims to provide the insights of how it is being explored and the future directions of how stochastic gradient actually works. So understanding about stochastic optimization, we have certain different topics, that is GD, that is gradient descent versus stochastic gradient descent. The next thing is mini-batch stochastic gradient descent. The next thing is impact of noise. Now what is this difference between gradient descent and stochastic gradient descent? As gradient descent computes the true value and stochastic gradient descent uses some noises and it estimates based on it. So what is this noise? See, when you talk, you will have some kind of disturbances, right? Or you will actually feel or get annoyed based on the different kinds of noise that is being associated. That is called as noise. So when you come with this stochastic gradient descent, noise is something which is the disturbance or the errors which come across when you are evaluating the values associated with it. What is this mini-batch stochastic gradient descent is nothing but it actually strikes a balance, it makes a balance. It averages the gradients over small batches and it works on the data based on it. Now what is this impact of noise? See, whenever you talk, you feel or you have any kind of noise, you get disturbed, right? So whenever you're handling with n number of data, lakhs and tons of data, when you have some errors based on every data, you get annoyed, right? So based on that, noise is also something which is associated with stochastic gradient descent, and that is something which actually help or it escapes the local minima. This aids doing the process in an efficient way. So we will have a landscape of loss function, that is, it has a high dimensionality, you have a local minima, and you have a difference called as a flat versus sharp. So what is this high dimensionality? Loss functions are high dimensionality and non-convex optimizations or visualizations, and they can be challenging. That is nothing but high dimensionality. The next thing is local minima. You have local minima and it actually exists. SCG needs to find good ones for the generalization. The next thing is flat versus sharp. Flat minimum or a flat thing is something which execute in a very minimal data or minimal values, and sharp thing is the thing which gives you the highest value and the accurate value which you actually want to implement. There are certain generalization, that is it bridging the gap between the training and testing process. That is nothing but there are certain steps that is associated with it, that is training error, or the next thing is test error, the next thing is overfitting and model complexity. What is this training errors? See, every mistakes that you overcome is called as mistakes or errors. Overcoming that and making it possible enough to train yourself is called as a training. The next thing is test error. So test error is having or dealing with some unseen or undiscovered data is called as a test error. Overfitting is when you have data and you have the same amount of values or data that is associated with it, it is called as an overfitting data. Model complexity is like how you work on the different kinds of models and what is the process involved with it. That is called as a model complexity. Now, this is the implicit regularization in stochastic gradient descent. The first thing is it favors the flat minima. The next thing is it flattens as regularization. The next thing is the learning rate. The next thing is batch size. What is this Flat minima, it is like you have to find the minimum value. Flattens as regularization is it improves the regularization patterns which is being evolved with it. The next thing is learning rate. How you learn and how you process the data. Now, what is the advanced techniques that is actually being implemented in this stochastic gradient descent is? The first thing is adaptive optimization, regularization method, next is early stopping. Adaptive optimization is nothing but it deals with atom, RMSprops, and it improves the different kinds of challenges. The next thing is regularization methods. The regularization methods includes dropout, batch normalization or batch regularization, and it reduces the overfitting process. Early stopping is better you have to stop the process prior getting any kind of negative impact, that is called as early stopping. Now, there are certain recent advantages or the recent advances that is being implemented in this process. The first thing is generalization bounds, lottery ticket, over parameterization. So, what is this generalization bound? You have to generalize the errors and you have to minimize the difficult things being executed in an efficient way. Next is lottery ticket is training or sub-networks which exist with large networks. Over parameterization is the role of network size is still debated. Now, conclusion or the further direction is all about you have a different process called stochastic gradient descent, normalization, and non-convex optimization, or whatever it is. Everything that is associated with this is something which is used for you to process the data in an efficient way and how you work on those data in a processed manner. So this is called as an optimization, non-convex optimization, and stochastic gradient descent. So hope you understood the topic in an efficient way, and if you have any doubts you can comment me in the comment section. I guess that that my session was clear enough. I will be meeting you with two different videos, that is my case study video and DT video which has been taken by my wonderful students. Based on those we will have certain activities and those processes will be associated with the further explanations. As of now, thank you. Have a good day.